Hi everyone, I'm Delmar,
And I'm Maddie.
and we're doing our demo today, which is how Alka-Seltzer works. So for our equipment, we're going to have our 250 milliliter beaker, our droppers, our stirring rod, an Alka-Seltzer tablet, vinegar, and our bromethanol blue indicator.
So first, we have 100 milliliters of water here, and we're going to add 5 to 10 drops of bromethanol blue indicator until the water turns a bluish purple color.
I'm just going to stir this.
So next we'll add a dropper full of vinegar until the water turns a yellow color.
And as you notice, when we add the vinegar, it's already starting to turn yellow. We're just going to give it a stir to speed that up.
Next we'll add our Alka-Seltzer tablet. And once you add it, the water will start to fizz and turn back to the blue color that we had before.
So while this happens, we're going to have to explain what's actually going on through pH, acids and bases, and indicators and buffers. So what the pH is, it's a numeric scale that ranges from 0 to 14. 0 is the most acidic, and 14 is the most basic, and water, which would be neutral, will be at 7. So for our experiment, the acid would be vinegar, and it has a pH of about 2.4.
In this experiment, the water has a pH of 7, which is neutral, and the vinegar has a pH of about 2.4, and the bromethanol blue has a pH of about 3.0 to 4.6, and these numbers were accessed from chemlibtext.org.
Mentioned earlier, we were saying that vinegar is an acid, and according to dictionary.com, an acid is composed of usually having a sour taste or is capable of neutralizing alkalis and rendering blue litmus paper, which contains hydrogen. And that can be replaced by a metal or an electropositive group to form a salt, or containing an atom that can be accepted as a pair of electrons from an acid or base.
So then next is a base, and a base is the opposite of an acid. As seen on the pH scale, bases describe solutions with a pH greater than 7, and there is a range of how basic a solution can be. Bases differ from acids in their potential for accepting rather than releasing hydrogen ions.
So since vinegar was our acid, our buffer would be the Alka-Seltzer tablet. And in this case, the buffer, which is our Alka-Seltzer tablet, it resists the change in pH when an acid is added to the solution.
So in the real world, according to scienceclarified.com, the human stomach produces hydrochloric acid, which is commonly known as stomach acid. Stomach acid is used in the digestion process. So for example, if a person eats something such as pizza, that's harder to break down. So the stomach may have to generate excess hydrochloric acid, and this can result in heartburn. So people with heartburn often take antacids, which contain a base such as aluminum hydroxide, and the antacid acts as a buffer and contains the base to calm down the stomach.
So to go along with our acids and bases, now we have buffers and indicators. An indicator is a chemical substance that undergoes a distinct observable change when in the conditions of the solution change. So this could be a color change, a precipitate formation, bubble formation, temperature change, or any other measurable quality. So for our experiment, we had a color change. You notice that it went from blue to yellow to back to blue.
And then another example is that if you own a pool, the pool, you need to test it to make sure the water is safe to swim in. So they sell kits at stores where you can buy pool indicators and test the pH of the pool water.
And you may not even realize this, but we actually use indicators in everyday life, such as in gardening, because like for gardening, certain plants grow better in certain more acidic soils, or certain plants might grow better in certain basic soils, such as like azaleas and pineapples. They grow best in basic soils, and then we got their violets that grow in acidic soils. And that was found from easychem.com. Just our experiment.